Let's talk about scoring, but first let's talk about the application that we built so far. So I'm going to share screens. So this is a bit of an eye test if you are, let's see, I want that one. This is a bit of an eye test. I'll try to keep the fonts relatively large. Can you guys see that okay? Anybody having problems? Need to bump the font?
No, okay.
Okay, so let's take a look at the path of a Phoenix request through here. So one of the things that I like to do with my LiveView classes is walk through what a new request goes through and then what happens when it hits LiveView. So everything is going to start with an endpoint, and you can picture this thing after this brief section is set up. There's this use, which basically calls the using macro in a file called Phoenix endpoint. Then there's a couple of module attributes which are used for setup. We start a couple of sockets for HTTP communication. And then everything else that you see, these are essentially sections of a long pipeline, right? So this, you can picture in your head a system that has all of these functions chained together. And there's a, and if you picture like a long slow motion reduce, you're on the right track, right? So these are reducer functions, or they would be if their first argument accepted the accumulator, right? The accumulator and enum reduce come second. But the accumulator in this case is a plug connection. And so it's going to flow all the way through these things. And then at the very end, you see that we have this thing called the Cram Web Router. And that's a great band name. So if you're writing those down, kind of pick that one up. Hey, we're Cram Web Router. We're playing the whatever. I don't know. I should have let that go like right at the beginning, right? And so, so anyway, we go into the router, and we're still following this long pipeline, and we define other pipelines. Now think about it. If you have an accumulator, if you have a reducer, everything takes an accumulator and returns an accumulator. And if you pipe a bunch of the reducers together, the first one takes an accumulator and returns one, then the last one is going to take an accumulator and return one, right? So the net impact is that this works exactly like any other reducer. Specifically, this works like a plug, right? Because a plug is a reducer that takes a connection. And so what we're going to do when we come into our application is we're going to match a route. And in this case, it's in this scope. This is the route that we're interested in. And it's going to fire a LiveView route, right? So the connection will come in to here, and then it's going to fire the game live. Well, the connection is going to have things like parameters, and it'll have the session. But one of the things that we do is fetch the session here to kind of take whatever's encrypted, make it unencrypted, and so on and so forth. And then we're going to go into the game live. So if we look in there, so I want you to think about this using in the terms of a pipeline also, right? So a LiveView has what's called a constructor, right? So that's the head of a pipe. It has reducers, right? And a reducer is something that changes the socket. And the socket is the data for the LiveView, right? That's our accumulator, right? And so what the whole model of LiveView is that you establish some data in the first place. You keep changing that socket through reducers, right? And most of those reducers are managed in this way. And then when along the way, we basically render results, and that's called a transformer, right? That transforms a socket into something else. And in this case, this transforms one small slice of the socket called socket.assigns. It's just one of the keys in the socket. This is where we put the custom data, and we're going to push this custom data down to the browser, but only the slices of that custom data that change. Right? So that's how LiveView works. And what we're doing is building a LiveView that's a memory game, right? So if I go to my LiveView, then I should be able to go to game here. All right. And so, here's my passage. And the idea is I can erase some of this. Oh, that's not good. Let's see what's happening. Do I need to rebuild? Oh, no route for game. Well, let's restart this. Make sure everything's compiling okay and that we're catching up. There's what's happening here. So I probably need to do an npm install. Have we changed? We might have changed version since I installed this one. Okay. Pay no attention to that warning. We're not going to solve that right now. Okay, let's try this again. All right. This is not your environment. Okay, so
finding.
What's that?
You got to npm rebuild node SAS to get past that. That just means your node version's changed. You compiled SAS originally. Maybe.
Yeah, I'm a little bit concerned that it's a little bit worse than that, but let's see. Now npm install again.
Yeah, you shouldn't even have to npm install again.
So,
Can you actually ignore that? Like if you've run this before and it's built, can you just ignore it, or is that not true?
well, it wasn't working, so I'm guessing no. I'm guessing no. Well, no error this time, so let's see. Okay. Okay. All right. So I was a little bit concerned. I did some major surgery to some of my dependencies with Brew. But anyway, so it looks like we're working okay. So what we did is we have this erase something reducer, and it's tracking some data on the back end. And what we'd like to do is to decide some metric, some way that we can score this game, right? So one of the things that I think that we need to do is maintain in the socket the original text, right? And then we want to compare against that text some type of, whatever the user types in. So we're going to need to put a form on the page. And so whatever the user types in, we need to kind of compare that against what actually is. So who has a suggestion for how we might do that comparison?
Levenstein distance.
All right. Is there a library for that?
It's in the standard library, isn't it?
It's actually in the standard library because they use it for the mixed test comparisons.
Okay. And so what does that look like?
I don't remember. I'll look it
How
up.
about something like that? How about the Myers difference instead? That gives me something
they
like this.
pulled Levenstein out.
Okay, so maybe they pulled it in favor of Myers distance.
They pulled it. Yeah, they pulled it.
Ah, and the Myers difference. Oh, well, those are completely different, right? How about we do something that's a little different, right? B, C, D. How about that? Okay. So the Myers difference basically tries to say if we have two functions, or if we have two strings, then and you make these series this series of edits. This is the shortest distance in terms of edits between the two strings, right? So I'm proposing that what we can do, and I'm going to leave for the homework, stripping out punctuation. But what we can do here is we can charge the user 1 point for a delete, 1 point for an insert, and then make the and then the rest of it we'll say we'll factor those out, and the low score wins, right? So if we do something like that, I could take that. So the Myers distance looks like that, right? I ought to be able to say the Myers distance. I ought to be able to pipe that through enum.filter, and right. And so we're going to say, how about reject? It's like the opposite of filter. We're going to throw out the things that match and keep everything else, right? And so we're going to throw out. So, and this is,
Hey, Bruce, can I interrupt and ask you a question also? Okay, so they replaced Levenstein with Jaro distance. So, so string.jaro distance, Jaro _ distance, and it gives back a number from 0 to 1. And it includes transpositions.
Oh, how about that? String 1, string 2. That's going to make things a lot easier, isn't it? Okay.
That's why I interrupted you.
Jaro distance. So this is your suggestion really sucks. It looks like
it's 0.
It gave us 0. What's up with that? 1 character. Maybe it'll be easier game then, right?
So 0 means the strings. I'm not sure exactly what it means, but I know 1.0 means they're exactly
the 1.0 is the same. Okay, so let's try string 1 equals.
Can you try putting B on the same position? Perhaps it's considering the position during the comparison.
So let's try this. Okay, so that's, and if they were the same, so that's 1. So why is line 12 closer to, I think that I don't want to score it in this way because I don't understand it. I bet we can code up a Myers function and use our reducers and kind of teach to those who let's try this with the Myers distance. Okay, so I've got the Myers distance here, and I'm going to take the Myers distance, and I'm going to filter out reject, and this is the the operation and the item, or the characters, and this is, we want to reject where the operation is equal to EQ, right? What's wrong here?
Missing function initialize for your.
I'm writing Julia. That's almost perfect Julia right there. All right. So, and then we can map over. So, in this time we want to, and this is the operator. We don't care about that. And then this is the string. And then we're going to do the, right? All right, what's wrong here? So is that string.length? Okay, there we go. And so now I could take that and pipe that to, is it sum? Yeah, okay. So this is my, this is going to be my score. And so I think that I want to drop this into, let's see, let's just put this in a, maybe a, let's just drop it into our core. So this is our eraser, and let's have a score. So let's say new file. Okay, and so we're going to say, do I want this to be a boundary or a core? I think that core is okay. And that, and we're going to skip the boundary on this one, or actually maybe we will expose this in the game of the, oh, let's see.
You could use your cram.ax for expose using some delegation functions.
Yeah,
for
yeah,
score.
that might work okay. So, but for now, yeah, that sounds good. And so for now, let's say that's def module, and we're going cram. Oh, we're just putting this in game, or we're putting this in cram, right? Let's just call this cram score. So I don't think that we built a boundary for this one, did we? I think that we accessed that directly. So we'll do the same thing here. Do as I say, not as I do. Okay, so, and we're going to have a def score, and this is the expected actual. And then we have this long thing, right? So there and there, right? And so this Myers distance was expected. And then we want to take the string Myers difference with actual. Is that right? And then we want to reject all the ones that are not equal. Okay, so that's going to give us a score. So we ought to be able to fire up. So let's see. Actual is. Is there Myers difference?
You got a typo. You got ACUTAL in the.
Oh, there it is. You know, it's a lot funnier if you just leave those errors and let me take like 20 or 30 minutes to find. As a dyslexic, that'll blow me up every time, right? All right. Thanks for your help on that one. Myers difference too. Yes, I would like that actually. Okay, let's try that again. And so we ought to be able to say gram score dot, man, I don't like score dot score. How about that? At least that communicates something. Okay, so now I could say cram.score to int, and then we're going to say ABC, and then just BC. That should give us a score of 1, and it does. And this should give us a score of 2, and it does. Okay, so now we have a great way to calculate the score. And so I think that probably the next thing that we should do is build a component. I think we have enough time to pull that off. So I think that what we're going to do here is actually use the generator. We'll leave that IEX terminal open, but okay, so now I want to build a live component. So the reason that I want to do this is to actually teach a little bit and kind of show you the structure of what a component looks like within LiveView, and how the life cycle works, and how good programmers, other than me, actually use LiveView components in the wild, right? I really learned a lot from the scaffolds that Jose and Chris build, because they really take a long time to get them right and spend some time with them. So I'm going to say, so let's see. Next time we probably are going to build a way to persist. Let's call them, I don't know, maybe we have a library of passages, right? So this speech is just one speech, but eventually probably what we want to do over time is to be able to draw this from a library, and those ought to sit in a database, and they ought to have some number of steps that's interesting to actually memorize this thing. Otherwise, it's just a one Shakespeare speech memorizer instead of something different that can be extended. So what I'd like to do is build a boundary layer and a core layer for what's called a context. And the context job would be to manage persistence. But I also want to do this in context of a problem where we're actually going to persist something and we're going to show a live view for it. And the reason that I want to do that is that I want to see how individual forms are wrapped and how components are used, and actually how we layer these things and what the life cycle looks like in LiveView. So let's think about this. So in the eraser, we have a couple of things that we need to pick up. We have the text, and then we have the schedule, and then the current step and total steps. So we have all these individual pieces. But so I think that that the pieces that we actually need when we build a new eraser, we actually need the text and we need the steps, right? So so when I create this, what I'd actually like to do is create a library, and that's like my boundary layer. And boundary layers represent the public API, but they also represent the place where uncertainty happens, right? So this is a Phoenix context. And you're going to see things like database access most frequently in the context. But if you're building things like OTP applications, this is where any process machinery has to live. The core is where certainty and functions that shouldn't fail live. And you should make sure that your data is clean before it reaches the core. So so you'll see that when we actually build, when we actually integrate this into our database code, we're going to feed in database data that has already been validated and clean. That's the only way that we're ever going to touch this constructor. And okay, so for now, let's go ahead and build. We'll build this boundary layer, this live view. I'm using the generator, and let's see what it's going to ask me for. So I'm going to say mix phoenix.gen.live. And so I'm not going to give it any options now, because I know that coming from the Phoenix team, this is going to have some good documentation. And it does. And you can see one of the things that's interesting to me is that this is so rich in terms of the types of Phoenix systems that use the same structure, right? So the options are, I can generate an HTML-based interface, I can generate a JSON-based API or LiveView, or I could just use the context, just the schema and the API layer. So this is the structure that we're going to use. So our context name, our boundary name, is a library, right? It is going to, it might have multiple types of text eventually, right? But for now, it has a literary passage, right? And so the passage is analogous to the user. That's the schema. That's the thing that actually connects to the database. And we have a singular and plural. I kind of like this. Some people say it should be inflected. as somebody who coded Rails for a long time and saw pluralization mistakes kind of go crazy, I'm against that idea. We take this, we take a little bit of extra time to be explicit, and it kind of pays us back over and over, right? And then we have the attributes and the types right here. And we and if we had them, we would have like we would have database references and things like that. So let's grab the LiveView version of this, and I'm going to fire that off. Before I fire it off, this is going to be my library. Name of the context. I call it the boundary, and this is going to be the literary passage. This is going to be passages. And there's going to be the number of steps, and that's an integer. And there's going to be text, and that is actually there's string, and that's I think 256 characters. We want ours to be longer. We want it to actually hold text. So this is a type text. It'll be a string in the model, but for the Postgres purposes, it'll have a slightly different type.
Makes it begin.
Yeah, thank you. Are some of you yelling the key combinations? Beginning of line, beginning of line. Okay, so we have to do a couple things. First, we have to migrate. So mix ecto.migrate. Okay, and then we have to drop these routes in. I know we're not going to use this, but I'm going to drop them in anyway, because it's easier to do now than later when we come back to this problem. So let's go into the routes. And so then I'm going to go within this. I'm going to drop in the browser scope. It's the only scope that I have right now. And so I should have a working scaffold. And let's just take a brief look at what this looks like. And what's the route? Anybody notice? We're going to passages, right? So I can go to, I should be able to go to my browser, and it's asking me to migrate. I already have now, but I can take this to passages. And one of the things that you'll notice is there's this, if I click this link, there's a pop-up, right? Now, the whole reason that we went through this exercise, even though we don't need this extra data, is that we want to build a component. And this is actually a component embedded in another component, right? So one of the things that you always get with Jose and Chris is beautiful layer code, and this is no different. In this case, there's the concept of a modal dialog, a pop-up window that has a close event, right? The second thing that you get, the second component that's in here is the form component itself, right? So there's this agnostic component that can hold any kind of markup or components in it that you want to. And then there's this other component. All it does is manage the form. And the nice thing about LiveView components is that they handle not just HTML markup, but they also handle state as well, and events as well. So one of the problems that you have with LiveView is composition. Like when I look at this individual page, most of this is completely independent of anything except strings, right? You could actually compose something beautifully just by layering more and more strings. But some of these things are related to action, right? They have events tied behind them, and processing the events is actually the reason that the components exist, right? And so when we look at this, what's actually happening is we are, there's another piece of the LiveView that runs in the parents process, but it gets events routed in its direction. So let's take a look at what that looks like. So in this case, we have this passage live, and you can see that it has two different live views, index and show. And it also has this thing called a form component. Well, what's a form component? So this is a LiveView component. And one of the things you will notice is that it has a life cycle that's a little bit different from the LiveView lifecycle. When you come into LiveView, it fires a mount, and the mount establishes the data. Well, in this case, you are not always coming in. You're not always initializing the component from scratch. There could be some action on the parents page that causes the component to change state. So it has, in addition to mount, which this component doesn't use a mount, you can use a mount to establish the state and leave it alone. But there's also this update, and you pass a series of options that should be updated on the component, right? And so just like a mount has params in session and a socket. This one has assigns, which are key value options in the socket. And the default version of this just dumps these params into the socket, right? But when you see a form, what you're looking at is managing change. So our job is to build a change set to manage this change for our form, should we decide to go this route, right? Okay. So if we want to use a Phoenix form, then ours is going to look like, when you look at the markup is going to look like this, right? So there's a problem. There's a fly in the ointment, right? So who sees the problem here? It's right here. What we want is actually our user to be able to build a change set, but change sets are hardwired to Ecto, right? It turns out they're not. It turns out that we can build something called a schemaless change set. And that's what we're going to do next. So we're going to attach our schemaless change set to the score. And so I can never remember how to do this, but we can use the Google machine, right? And so let's look for okay, so this is Ecto change set. And if you see all the way down here, you can see I've done this a time or two. This is what the strategy is going to look like, right? So one of the things that we have to do is establish a type for our struct, right? So I have to have a Devstruct. And in our case, our score doesn't need anything beyond just the string, right? So I'm going to use the Devstruct, and that's going to help Ecto establish some of this data. So I'm going to grab this data, and we're going to use this to kind of help us. So I think that all we're going to need is the cast. I don't think we have to do any validation. I think that if we allow the user to have maybe we validate a length of 1 or something like that. But let's go ahead and grab this, and we're going to apply this to the score. And so actually, let's apply this to the bottom just to, and these are notes. I'm just going to leave this commit in place. And I'm going to say, okay, so what are the elements that we need? Well, we need some kind of a structure, right? And so our struct is, I'm going to do a Devstruct, and this is just going to have text, and that's it, right? And so, wow, so I have those two cursors open the whole time. Okay, so so that's check. Oh, holy cow. All right, so check that off, and then I'm also going to need some types, and I'll specify these as a module attribute. And so this is going to say text is a string. Beautiful. And so the now I have my type set up. And so now all I need to do is establish a change set. So this says change set equals. We're going to return this as a function, right? So, and so let's take a struct. Let's take a score and the changes. And you know, what's interesting is that I probably am not going to process this change set more than once, right? I'm probably going to only worry about the change set when I build the form in the first place. So I'm going to go ahead and take this score away here. And I'm going to drop in the data right here. So rather than user types, this is going to be and this is a module attribute, right? And I want to cast this thing. I want to cast the params and then the keys of the types, which is just going to be text right here, right? So all this says is that I want to make sure that that only the types that I specify are allowed in, and that they're cast the appropriate type in the case that there's anything any kind of problem with them. So okay, and so I could do a validate required. I could do a validate length. Do I want to do that? I think I don't want to do this. I think I'm going to live with this much. But this will allow me to build a new change set, right? And so, in fact, I wonder, since we're just building this up, no, let's go ahead and do it like that. We'll default this to, I think params is supposed to be a map. Yeah, so I think that that's going to work fine. So if we decide to kind of play around a little bit and build our change over time, we can do that. But what this work has allowed us to do is to express the concept of change to our LiveView, right? And so we're not married to Ecto to actually express the idea of our change set. So I'm going to start actually coding just a raw form in place. And we'll probably go, I don't know, 10 minutes after the hour. And if we're done, we're done. If we're not, you'll have an excuse to come back again. But what I'd like to be able to do is I'd like to be able to express the difference as our, I'd like to be able to express the Myers difference in our change set. So let's go ahead and compile this much. Okay, so we can recompile. Okay, so undefined function types. So I think I saw that earlier. Yeah, that's right here. We have a types, but it's a module attribute. And so let's try that again. Okay, struct does not exist and is okay. That's fair enough. You got me. Guilty. And so maybe I should do that. This is the same thing. This is the function that that Elixir provides for building a default struct. If you want to do %__ module _ open close, it's the same thing. So let's try it. Okay, beautiful. So like for example, if I called cram . Right, so I get the text of nil, right? And maybe I want to default to this thing of text to an empty string just to kind of close that little potential problem. Okay, great. And so then if I apply an empty chain set to this thing, then I'm still going to be okay. Right? All right. So now we ought to be able to say param right. And so now I get a valid chain set. Right? So we could play with this chain set a little bit by building in a length, right? So let's see, does anybody off the top of their head remember what this looks like? Is this just a text and a, so it has to be at least 2 characters, just like that?
I think you need to use keyword
Keyword list,
notations,
okay.
I think.
Like that?
I don't remember right now. You
Let's-
need to pass the type in minimal 2, I think. I think it's type, it's your text.
Oh,
I guess.
Like that? Let's try that.
Yes, I think so.
Okay, so that's valid. Valid true. So it didn't like that. Yeah, I don't think I'm going to chase this down. Thanks for that. Appreciate it. So yours was correct. I didn't actually get that right. Okay. So I think that what we want to do now is show a form. And actually, let's drop the form in line rather than using the component off the bat. Let's drop the form in line. Let's start here, and then we'll extract it into a component next week when we do a little bit of, or next time that we get together when we do a little refactoring. Cool. So, okay, so we're going into game live. We're going to memorize this much. And let's see, so if form for chain set, right? And so this needs to be, so the chain set, I needed a chain set in here, right? And this is cram dot score dot change. Okay. So now I've got a chain set ID passage form. So we don't want to use the same name here. We do need an ID. And the reason is that the only difference between a stateless and a stateful component is that a stateful component is allowed to manage its own state. But then we need to be able to send it events. And the way that I do that is with an ID. So we're gonna call this the score form, right? And the target is myself. We're going to take this off. So essentially, that is the shorthand for building the ID. And this will make a lot more sense when we're in another component, right? So we're going to do Phoenix change and validate. We're going to strike that and do a Phoenix submit of save, right? And so this is a label. Okay. Okay. So what kind of input is a text area? I never can remember this. Anybody know?
Is it text area? I thought it was text area.
Is it? Great. Is it one word or underscore?
I never know. I have one. Let me find it.
Okay.
I'd go for an underscore.
Okay. Let's see if this much is working.
It's one word.
Okay, text area. It's
Darn.
always the opposite of what we guess, right?
It is.
Always, always. What's funny is since I've been doing 2 languages, I didn't expect it to hit me this much, but it really has. Okay, so I'm going to go to game. Okay, memorize this much. And then now we have a form, right? And so we have, and this is going to be a save. And so, yeah, so one of the things that we could do is we could merge these ideas together, right? And so one of the things that we probably want to do is put a score in here. Okay, so the score is going to be 0 initially, and the text is going to be, did we keep the original passage? Let's keep it now. Origin. Life is a dyslexic, huh? And let's pop that in there. Okay. So now we have the original text in here. And so we could say, so this is going to do a save. So one of the things that we can do is make this our save, right? Right. And this we can do this socket erase. And I know you hate me now. You'll love me a little bit later. This is a reducer of size 1. And I know people hate that. What we're eventually going to do is drop another reducer here that's called score. Compute score. And so this is going to be assign socket. Let's do this. Socket. Right? Okay, and so now I can just do like that. Okay, so let's see what we have here. So let's save. Do you see the score bouncing up? No, you don't, because we're not showing a score. Okay, so so we're going to put the score in. I have so little imagination. Just the headings. That's my whole user interface. All right. And we'll do a score. And then close that out. And so now, okay, so the score is growing. It's not exactly the score that we want to, right? And so I want to do something else. I want to have a shorter speech so that we aren't going to kill ourselves memorizing that bit of Shakespeare, which is marvelous Shakespeare, but it's also marvelously long. So somebody give me a movie quote or TV show quote.
Hasta la vista.
I decided to make this all in Spanish, right? Or all in Spanish would have been like that, right, baby? Or is it? Which is it? Somebody look it up. Somebody help me. Where should the accent? Baby? Baby?
At the end.
Is it? Hasta la vista, baby. Okay, so now we're going to drop that into our score. So this is going to be We're going to go to the game live. And so and then we want the short text here, right? Actually, what I'm going to do, I'm going to set that up here, right? Beautiful. All right, let's see if how we're looking here. Hasta la vista, baby. Yeah, but the terrible thing is now the person who is actually playing the game has to get that accent character at the end, right? Do you know how to type your accents? Okay, what's left? Let's see if we are actually picking up that score in our, so what I'm going to do is I'm going to actually see what's actually being passed when we type something, right? So this isn't going to match, so it's going to blow up. I use this technique a lot with my logs, right? So we're looking for that text that I just typed, right? So boom, so that blew up, right? So now I ought to be able to go here. And so this is the no function clause. And here's my handle event right here, right? And there's the token, and there's the score right there, right? So the score, so that's what I want to match, right? So now I can go into here and I can drop in that pattern, right? Like that. And this is obviously, and this is actually actual, right? No, this is expected. That's the actual. Okay, so let's see. So I've picked off the actual, and now to score it, right? And this is going to be cram.score.to int, and I actually need to provide the actual and socket.assigns.original. And actually, I'm going to label this concept, right?
Bruce,
Yeah.
I think you need to change the order your params for cram score.
And I also need the actual here, right? Should work either way, but we'll call that good. Cool. Thanks. Was that Herminio? The do at line, let's see, did I blow that up? 47, probably so. 47.
You assign.
Say again?
Two parentheses and you assign.
Oh, thank you. Socket assign, got you, yeah. And you know what? I think I want to one line this one. Okay, let's see. Right? Aha, look at that. And that's it. So we have a working score. All right. So I think that next time, what we'll do is extract this piece of work and put it in a component. And then I think it would be cool to add a picker on the front end where we can actually record a few different passages. And if you guys want to, we could actually even share the keyboard if you think that that might be fun. Yeah. So I think that's it. Anybody who'd like to go, I know we're over a little bit, but I'll take a few questions. What did everybody think? Anybody have fun?
Bruce, I just got I was like wondering if there's like a concept to share forms, like when you are like editing, update, but if you would like to reuse some form in different lives, is that possible? Is there like a
Yeah. So that's the component pattern, right? So what we've done is drop this in here. What Jose has done, or actually Jose and Chris have done, they have this form component, right? And this has two pieces of important behavior that are important, right? One is the life cycle, which establishes the state, and the second is it manages the events, right? And so this component has an ID. So when it's rendered, so I'll show you that in a second, but it also has this markup so that you could use this component in any way that you want to. Now, the way that it's rendered, it's actually called in this live helper. There's this thing called live modal, right? And so this actually includes the modal component here. And so if we look at the modal component, this is where it actually says, hey, here's the modal component. This is called a live component. This is the socket. This is the component, which was established in the socket assigns. And these are the options, right? And so you'll notice that when we specified the component in live helpers here, live helpers, yeah. So one of the things that we did was we set up a modal options, right? And this is the one that makes it a stateful component so that we could send it events, right? So when you're sharing something in LiveView, the important part is not just to share the markup, though that's important. You also have to think about, does this have behavior? Does this have a state life cycle that I need to manage? And if it does, then you have to share that as a stateful component. So that's the terminology and the techniques that you're looking for. Good question. Thanks.
Thank you.
You're welcome.
Bruce, do you know if that live modal stuff, is that new? Is that in like the most recent version?
So the live modal is actually, it's a helper. It's not a LiveView function. Okay. And so you see this is just a live helper, right? And
yeah.
Live modal is right there. It's if you look at it, then the only behaviors that this supports is close, right? That's it. So it's just a little CSS magic to drop everything else in the background, drop this div with a form on it, and that's it. It's beautifully layered, just impeccably layered. And so if you look at the keystrokes, right? So we capture the close click. We capture the key down for close, and so we send them both to the same place. We capture so the key that it maps onto the close is escape. So escape will close it, and so will a click on this button, which is just a return to, right? It's a redirect, right? So when you look at the implementation of the close, that's in the modal. That's right here, right? So push patch. All patch does is fires a function called handle params, right? And in this case, it's going to say handle the parameters to send me back to the original view that I was on, which is so this is not sending the push patch to this component. It's sending it to my parent, which is right here, right? And so, yep. Which is cool, right? It never re-renders any of that. It never has to re-establish the state for any of that index stuff. All it does is reset the component, which resets the live action. And when you reset the live action, what happens is this doesn't fire anymore, right? So if the live action is new, then it shows. If it's edit, it shows. If it's index, which is where we came from, it doesn't show anymore.
Yeah, super cool.
Beautiful, beautiful. No more complicated than it needs to be, right?
When's your book coming out on LiveView?
Yeah, so I am starting a business, right? So this is more information that you really need to know, but I'm starting a business. And one of the things that the ACA does is there are tax consequences, right? For making too much on certain healthcare plans. So I'm trying to release after the book would cause revenue for this year. So we'll do it as quickly after December 1st as we can. So so that's kind of what we're looking for. We have so Sophie is actually moving a lot faster than I am. She's going to be a better author than me someday. She's a wonderful author and just works tirelessly. So she is about 8 chapters in, and I'm about 6 chapters in. She's actually writing the code. I'm writing the, we call that the scaffold, right? And she kind of shapes the concepts for the book, and I write the prose, keep the voice consistent. It's the same split of work that we had with the Programming Phoenix book.
That's cool.
Yeah, thanks. More questions? Hey, I don't want to keep everybody. I know you've been on Zoom all day probably. So thanks for coming out, and love to see you guys on Groxio, Patrick, Adaminio, and all you other Groxio customers. It's been great to have you. Take care, everybody.
Thanks, Bruce. Thanks, everybody.
Yeah, thanks
Thanks
everyone.
a lot.